What's up, Ergo peeps? This is James, alumni, former Ergo slash breaks lead. I wanted to make a video, maybe a video series of lectures covering concepts covered in this course here. I put the link down below to this course that covers ergonomics and automotive design in general. It's a pretty in-depth course, and some of it can be kind of hard to understand. It's a lot of information overload sometimes. So I wanted to make some videos that, kind of just give the layman's terms and kind of break it down more simply and also relates it more to Formula SAE specifically. This course kind of covers more just consumer vehicles and in general. So let's dive right in. The first section of the course is called Ergonomics and its Domain of Specializations. So what is the definition of ergonomics? Ergonomics is actually a word derived from Greek, ergon meaning work and nomos meaning law. In other words, the law of work. Now, what does this mean? Well, the key principle of ergonomics, I always like to explain this with examples, pictures. Everybody loves pictures. So let's say we got to cook a bowl of soup. All right, we got to cook some soup. Well, in our first scenario, we start with our bowl of soup, and we need to get someone that's, flexible enough and has the proper mobility and sit them down and cook this bowl of soup where it's placed, right where it's placed. Put a little box under here so that they can sit down and reach it right here. So we'll call this scenario A. Now, our next scenario, we're going to start with our person first. And we still got to cook a bowl of soup, but since we're starting with our person, let's build ourselves a table so that this person can reach the soup and cook it and all that. So we'll call this scenario B. What is the difference between these two scenarios? Well, in scenario A, as you recall, we started with our soup and we had to fit the person to the task. In other words, the human had to adapt to the task. Now in scenario B, we started with the person and then we fit the task to the person. And otherwise, the task was modified per the person's requirements. And that, in essence, is the key principle of ergonomics. We always prefer this scenario. We're always trying to fit the task to the person, not fit the person to the task. We don't want the person or driver, in our case, to adapt to whatever they're doing. We want to adapt the vehicle components or the machine components so that it makes the driver or the person or operator's job easier. Now, there are three components that make up the human vehicle system. The first being the human or the driver, in our case. The second being the machine or the machine tools or vehicle components. And the third being the surrounding physical environment. And in ergonomics, we're always focused on the interaction between the human or driver and the machine or vehicle. This is always what we're focusing on. Now, there are three factors that affect this interaction. The first are physical factors. The second is cognitive factors. And the third is environmental factors. I will go a little bit in depth in each of those in this next slide. Physical factors are the more obvious ones, the more obvious thing that you think of when you think of ergonomics. I always pronounce this so wrong. Anthropometry, whatever it's called. That's essentially the length of different people's legs or hip width or arm length or overall height. Anthropometry, whatever, however you pronounce it. So driver anthropometry, posture and biomechanics, um, and as well as how our controls are placed, pedal box geometry, the amount of effort, we call it pedal effort, or in other words, force requirements by the driver to press on the brake pedal or gas pedal or clutch pedal. These are all the physical factors that affect the interaction between the driver and the vehicle. Now, one of the less obvious ones are cognitive factors, something you don't immediately think of when you think of ergonomics. This essentially relates to the driver's reaction time, decision making, and situational awareness. Well, how can we affect those things? Mainly with our dashboard, our controls that we have, our buttons, displays, you know, labels that are on different controls, how intuitive the controls are. Do you know without ever driving this car and first getting into it, do you know what the controls do? That sort of thing. And another less obvious one are environmental factors, things that are more or less out of our controls, at least in terms of ergonomics. Things like vibration and noise from the road, or temperature outside and how that affects the driver's fatigue. Conditions of the road, if the road is slippery, track layout, lighting, any disturbances. Now, vibrations and noise can kind of be controlled by suspension, but that's sort of out of the realms of ergonomics, but it's still a system that we do, a sub team that we do work with. Now, human factors and ergonomics. These are two terms that are used sort of interchangeably when talking about ergonomics. So, what is human factors? Essentially, when ergonomics was still up and coming concept, during the early stages, human factors was the version of ergonomics developed in the United States. And it mainly covered issues relating to those cognitive aspects that we talked about. So, driver reaction time to decision making, mental workload, that's everything that covers human factors. Now, ergonomics, the one we're more familiar with, physical aspects, kind of covering these physical aspects here, based out of Europe. Um, and now, in present day, these two terms encompass both cognitive and physical aspects in present day. So that's why both of these terms are used interchangeably in present day because they both cover cognitive and physical aspects. So if you ever see human factors, they're talking about ergonomics. If you talk about ergonomics, they're talking about human factors. But just so that you know, if you see maybe an older paper that's talking about human factors, it's probably mostly covering cognitive aspects. So just keep that in mind, the origins of the two names, but they're used interchangeably now in present day. The second section of the course is called the role of the ergonomist in the automotive design process. These are the steps in any vehicle design, all the steps. There's different versions of these, but this is in general what steps take place. You got understanding driver needs and expectations, product planning, styling engineering. Detailed engineering is talking about subsystem design, so powertrain, suspension, electrical, all those things. That's what I mean by detailed engineering. And then prototyping, testing, part design, and plant construction, meaning overall vehicle, I think construction then of vehicles produced. And then we get our driver feedback and analysis. Now, keep in mind, all of these steps sort of happen at the same time, or some of them happen in succession. Um, but something else to keep in mind is the focus of us as the ergonomist or an ergonomics team. We always start with understanding the driver needs and expectations. And we always end with driver feedback analysis. So these first and last steps. Now, what is our role as an ergonomics team in the overall vehicle design? Essentially, our job is to provide ergonomic guidelines and user data, things like we discussed before, anthropometry, driver feedback, things like that. We're trying to integrate those things into the overall design of the vehicle with other subsystems. Ergonomics often works with all other subsystems. It touches all of them. And so our job is to evaluate the vehicle design in those subsystems from an ergonomic perspective. Now, there are three different types of research in ergonomics for automotive design. The first being descriptive, where you're just basically collecting data. Anthropometry data is the most important. You're talking about flexion, hypertension, range of motion, even of all your drivers, your leg length, arm length, overall height, and you're maybe getting an average of the drivers. Now, this is specifically drivers that are going to be driving the car that you are designing. Not just drivers in general and general public, specifically your drivers. So if you want to design a cockpit, maybe you'll take data from your different drivers of different heights and lengths, and you'll take the average and use that and build a test dummy and use that test dummy as your average, 90th percentile, 50th percentile, or whatever it is, to design your car. Now, experimental research is one that we're more familiar with on our ergonomics team, where we're basically testing different design variables and then gauging driver comfort performance. Maybe we'll have a new steering wheel design, we'll change the width or thickness, and then have the drivers put it on the car and try it out and score it, tell us how it affects different things. We could also analyze lap times or fatigue studies, how tired the drivers get, or just some surveys. So any type of experimental data research. Now, evaluative, this basically is just talking about the old versus the new with our team and sometimes other teams too. So essentially, we could compare cockpit ergonomics, steering wheel layout, pedal positioning, different things, and what works for. Maybe there are things from this old design that drivers actually really liked that we could implement on a newer design. Or maybe there's another team that has something that we could use as well. A little bit of it's benchmarking. Now, this is a modified version of what is in the course, phases of ergonomics design and Formula SAE. There's the pre-conceptual phase, conceptual phase, pre-design, detailed, and post-design. This last stage in the course is actually called post-design and market feedback. So again, the course is sort of designed around consumer vehicles and large companies that make multiple cars. I sort of just refined this to focus more around FSAE, so that's why some of these might look a little different. So this more relates more to what we're doing. So anyways, we have our pre-conceptual phase. This is essentially where you're defining your problem, your project, and you're having your limitations. You put your limitations, your constraints. Are you limited to certain materials? Do you have a price limitation? What are goals? What is our chief engineer? What do they set as goals for each of our subs teams? This is also the stage where we collect data on our drivers. What drivers are going to be driving? What is their dimensions, anthropometry? Then we move on to the conceptual phase where we're developing some initial concepts, either CADing them up or sketching them. And then after that, we do the pre-design phase where you're validating these concepts and using ergonomic analysis tools like an Ergo buck or maybe a model with a human that you put into your chassis model and put your ergonomic components on. You're testing fitment. Then you move on to your detailed design phase. This is where you're kind of refining all of the fine little details. Maybe you have an Ergo buck that's more detailed with 3D printed parts on it, and you have drivers hooked up with their full gear. You want to make any changes before you actually start making these parts, machining them. Then post-design and driver feedback. So this is after the car is complete. You're doing testing, you're doing some shakedowns, and you try to gather as much driver feedback as you can so that you can focus on what changes maybe could be made for future designs So this is more so for next year. You want to collect that data so that you can analyze it and do the benchmarking all over again. So we'll go in each of these phases in depth. So first we got the pre-conceptual phase. The first step of the pre-conceptual phase is benchmarking. I have our 2024 car, and I think our first car that we ever made on this team back in 2016 or 2018. Not sure, wasn't around at that time. So we're essentially analyzing past FSA vehicles from our team and other teams. These are all competition winning vehicles that you see on the screen here. It's University of Michigan, Ann Arbor. You've got University of Stuttgart, a German team. You got University of Illinois, who won 2 times in a row. University of Stuttgart also won multiple times in a row. And then you have Ohio State, who won recently in the last competition, 2024. So a lot of these teams have similar things that they do. Maybe they do similar shifter designs, or they take a certain approach. Maybe they have a way of creating a certain seat design. This, for instance, that's how we got our idea for our expanding foam to create custom molds for drivers. It's actually a concept that Illinois uses and some other teams do as well. So you're kind of just finding the best practices. What is the standard for ergonomics teams? What are all the good teams doing? And how can we implement some of those things on our car? Next is user needs assessment. So this is probably one of the most important steps, if not the most important step. You're gauging what your drivers prefer, and you're also gathering this data, anthropometric data, height range, arm length, leg reach, shoulder width, and maybe you're creating a model of your average dummy that sort of is supposed to represent the average Joe on your team. You're conducting interviews, maybe creating surveys. Maybe you have some rough 3D printed designs and you want to get drivers' feedback on it. That's what we were doing when we were designing steering wheel back in 2023, 2024 design cycle. Yeah, a good example is if a shorter driver had difficulty reaching the shifter in the previous car, maybe you would adjust the location accordingly. So different things like that. Next would be regulatory compliance and standards review. This is essentially just saying, make sure our car follows the rules, all safety rules, FSAE rules. There are certain restrictions on helmet clearance from the roll hoops of the chassis. There are certain dimensions that a person's head has to be in, person's shoulder has to be in. This is kind of a standard. So just make sure that we're following the standard. There are also harness mounting points that have certain restrictions. There are guidelines on that. So this is basically just follow all rules and be within compliance with FSAE rules. Now we're moving into the conceptual phase. First part of this is brainstorming and data interpretation, the data you've collected in the previous phase. Ergonomics is always collaborating with other sub-teams because it's so central to everything. You got your chassis, suspension, electrical are the main ones that we work with, and other sub-teams as well. And we're trying to get our drivers' preferences integrated into their designs because often their designs play back into ours. Electrical is definitely working with us a lot on the dash for sure. Chassis with the cockpit. And this is kind of where we consider trade-offs also. Maybe a lower seating might improve aerodynamics, but reduce visibility, things like that, or center of gravity. Next will be when you develop your concept sketches and models, assessing the cockpit layout, working with the chassis team, like I said again, making sure that the placement is okay, steering wheel placement is okay, maybe using a test dummy to test that. Or maybe having some 3D printed models or cardboard mock-ups, early mock-ups before you build a test buck might be doable. Next is basically just narrowing down different cockpit or steering wheel or shifter, different designs, different concepts, which are most feasible. Obviously, we don't have on our team, the amount of resources to build a monocoque chassis. So we would go for a typical steel um, or aluminum chassis. Then we get to the pre-design phase. Um, Something that we've never really done on our Ergo team before is create a human model or do human model assessment, a digital human model assessment. There are certain softwares. I think Siemens has a actual mannequins built into the software that you can just use, and they're based on the 90th or 95th percentile. So either Siemens or CATIA, can't remember which, but it's still possible to build a test mannequin in SolidWorks as well. And it's a great way to simulate driver fit without building the test buck. If you have your chassis model already in hand, you can just put your little dummy in there and use that data that you've collected from your drivers to build this dummy. Maybe you'll have a dummy for your shortest driver, one for your tallest driver, or you'll have just one dummy that kind of represents all drivers, an average of all your drivers. It's a great way to test fitment and really testing whether driver can easily reach different controls like the steering wheel or shifter or pedals. It's the main thing you're testing here. Next is actually building an actual test buck, which is one of the probably the best way to test different things on ergonomics. Um, you can do different. You can do it in different ways. Wooden is usually the best, but some have done PVC and other things. Um, this is also a great way to test visibility, reaching the controls, entry and exit of your vehicle. Also, something that we will be great to do is actually using a simulator. There's an Assetto Corsa. They have an FSAE car mod that actually models the FSAE car, and I think they have a simulation of the competition endurance track as well. So that'd be something great to get drivers on. Or you might even consider maybe combining an ErgoBuck with this simulator software, have them wear a VR headset, maybe integrate the controls so that they can control the simulator. Something we've never really done before. I'm not sure if other teams have done, but something that might be really cool for drivers to get a taste of what the car might actually even feel like when driving in simulator. Next would be component placement and human factor considerations, those things we talked about, those cognitive aspects. Can the driver intuitively know what buttons do what? Are these buttons labeled? See, these buttons aren't labeled all that great, so it's not easy to tell what they actually do. So having them labeled, maybe having a good display, pop-up display. Can the driver see what speed they're at accurately and with good visibility? Can they reach different switches? Kill switch in emergency? Can they reach the shifter okay? Is the pedal positioning all right? Do they get tired after using the pedals? Things like that. Then we get to our detailed design phase. This is where we're doing kind of our refinements and we're getting ready to make our final changes before we submit drawings to the manufacturing team. Usability test is basically getting your actual drivers to get in full gear and have sort of a final test buck that gives a true test of what the car will feel like. And maybe even having some 3D printed components on here for them to test to get a better feel of what it's like and making any changes if they feel uncomfortable or they feel they have too much effort when they're steering or their shifting isn't all that great. So this is your final chance to make any changes that you might need before stuff is made. Test of a egress. Egress is something that's very important in competition. You have to be able to exit the car in under 5 seconds, detaching the steering wheel and everything. So you can do egress test with your test buck. Um, you can also check, seating position, visibilities of control, and all those things with your test buck. Then we get to the last phase, which is the post-design and driver feedback phase. This is where your car is complete and pretty much all of your designs are final. Maybe there might be a small thing that you can change to a component if you have the resources, but more or less everything is pretty final. You do testing, you might have a test track and maybe isolate a certain ergonomic part, like the steering wheel or shifting, that you want to test and build your own test track or have someone build it for you, like someone that's on the testing team or the testing lead, build some sort of track that best encompasses the ergonomic performance and test it the best. And just see what the drivers struggle with. Do they struggle to see the dash at high speeds? Maybe reposition it, or are the buttons clear? Is there a glare when they have their helmet on when the screen is going? Things like that. And after you gather that data, whatever it is, you analyze that data, and data at competition as well is great to get. But I know competition things can be kind of heat of the moment, so it can be kind of tough to gather data. But this is more so for future designs. See how the car performs, and then leading to the next step, we translate that research into future guidelines, use that competition feedback to refine next year's car. So that pretty much makes up everything for this presentation, guys. Let me know if you want me to make more of these videos. This encompasses pretty much the only parts of the course that I've actually went through and covered. Like I said, if you want more in depth and kind of a more general perspective of automotive design, you can click on this link here. This link should work, and or you can type it in, copy it. Uh, there's a bunch of videos online from Professor. So, yeah, that's pretty much it. Thanks, guys.